Very good morning, class. Our lesson today is about alcohol. You can refer this to your textbook in page 76. Look at this picture. This is photograph 2.6 showing various example of uses of alcohol. Kegunaan alkohol dalam kehidupan seharian. Antiseptik ada di dalam hand sanitizer. Perfume, minyak wangi, solvent, pelarut, and fuel. So what is alcohol? Actually, alcohol is non-hydrocarbon. Non-hydrocarbon meaning that it is not only hydrogen and carbon inside. There is other substance, other atom inside, which is oxygen atoms. So alcohol contains carbon, hydrogen, and oxygen atoms. So that is why it is called as non-hydrocarbon, because it has oxygen inside. So what is the functional group of alcohol? Functional group of alcohol is OH. OH, hydroxyl group. The hydroxyl group OH is different from the hydroxide ion. I told you before, there is another ion that you have learned. This one is called anion, a negatively charged ion. Okay, so this anion, which is called hydroxide ion, are not in alcohol. This is not the same. OH minus and hydroxyl tidak sama, not the same. Okay, so that is the functional group. We call it hydroxyl group. The general formula for alcohol is CnH2n plus 1 OH, where N starts with 1, 2, 3. Okay, let us learn the three members of alcohol. You understand that the first member is starting from meth. So if it's the first member of alcohol, we call it methanol. The second one will be called ethanol. Then the third one will be called propanol. So what is the general formula for the first, second, and third member? The first member, C, it starts from 1. C1, we omit 1, we do not write 1. C1, H, 2 times 1 is 2, 2 plus 1 is 3. So CH3OH. This is the first member, which is methanol molecular formula. The second one is ethanol. Ethanol is C2, because it starts from 2, the second member. H, 2 times 2, 4 plus 1, 5. OH. And the third one, propanol, should be C3H7OH, and so on. So these are the first, second, third member of alcohol homologous series. Let us look at the example here. The third member, N, is 3. So the molecular, as I have taught you just now, is C3H7OH. How to draw the structural formula? You start from C. So you draw C, C, C. Single, single. There is no double bond between the carbon atom in alcohol. Only single bond. H7. So you draw 1, 2, 3, 4, 5, 6, 7. H. And then this is the functional group. You can draw it this way, or you can draw it this way. Look at this structural formula. A is correct, where the bond from the C is bonded to the O in hydroxyl group. But the structural formula for B is wrong. Look at the bond. The bond is bonded to the hydrogen atom in hydroxyl group. This is not correct. So let us discuss why structural formula A is correctly drawn while structural formula B is incorrect. If you still remember, we have learned about hydrogen bond in Form 4. Form 4, Chapter 5. Let us look at your textbook, Form 4 textbook. If you still remember, ethanol, which we have learned just now, ethanol is soluble in water. If you still remember, we have learned about hydrogen bond in chapter 5, where the hydrogen bond, where the meaning of hydrogen bond is like this. This is the meaning of hydrogen bond. Let me show you what you have learned in Form 4. Hydrogen bonds are attraction forces between hydrogen atom that has bonded with an atom of high electronegativity such as nitrogen, oxygen or fluorine with nitrogen, oxygen or fluorine in another molecule. Meaning to say, when you have one molecule that has O in it, which is high electronegativity, and you have another molecule with O in it bonded to H, that O with the high electronegativity can form hydrogen bond with the H from another molecule that has O in it. Let us look at the example that we were talking about in chapter 2 from 5, where we discussed about ethanol earlier. We discussed about ethanol. So ethanol is soluble in water. If you look at this structural formula, you can understand that this actually is coming from CnH2n plus 1 OH, where N is equal to 2. Why N is equal to 2? Because ethanol is the second member. So it is C2H5OH. So when you draw the C first, C, and then followed by H, 1, 2, 3, 4, 5 H, and followed by OH. OH is drawn this way, or like what you see in your textbook just now, in this way, or you can also draw in this way, like this. As long as it stays together as a group, do not separate it, one O here, one H here. That is wrong. As long as it is in one group. So I let you know why the structural formula for B just now was wrong. Let us look at this one. Ethanol is soluble in water. When it is soluble in water, meaning that it can form another bond with the water. Okay, let us read this one. Ethanol consists of hydrogen atom that form covalent bond with oxygen atom. So this is ethanol. Ethanol that has hydrogen atom that form covalent bond with the oxygen atom. This is hydrogen, this is oxygen, this is hydroxyl, and they are bonded by covalent bond. So the oxygen atom in ethanol, this one, as I have mentioned earlier, oxygen is a high electronegativity atom. Okay, so since it has oxygen in ethanol molecule, so they can form hydrogen bond with the hydrogen atom from another water molecule. So that is why ethanol is soluble in water, because the oxygen, which is high in electronegativity, will form a hydrogen bond with H from the water, So that is why the drawing just now like this is correct. If your drawing is like this, the bond is to the O and then H. I draw it one more time for you to see it clearly. Okay, if the bonding is from C to O and then H, this is correct. This is correct. Why? Because you leave one more bond for O to bond with H to O, water. Okay, so you remember, whenever you draw alcohol, C, the bond must bonded to the O, high electronegativity ion, OH, okay, to the O, not to the H. Whenever you draw, you must remember this bond is to the O. Why? Because this O will form another hydrogen bond with the water molecule. Why it form hydrogen bond? Because it is soluble in water, larut di dalam air. So that is the reason why. So now that you understand why the structural formula is correct this way, let us discuss about the naming. Naming of straight chain alcohol according to the IUPAC nomenclature. So how to name a straight chain? Straight, lurus, not the branch one, bukan yang bercabang. Determine the number of carbon atom in the longest carbon chain containing the OH hydroxyl group to derive the name of alkane. So what you do, you determine first. I use a highlighter. I highlight this one. This is the longest chain, the longest carbon chain, straight carbon chain. So how many atom of carbon? There are 3. 1, 2, 3. So 3 carbon atom means it's a prop. Okay, it's a prop. And then replace the E ending from the alkane name with ol. So it will be changed to propanol. If it's an alkane, it is called propane. If it's an alcohol, it's called propanol. So hydroxyl position is very important. Where does the functional group situated at? If it is situated in the first carbon, we will call it as propan-1-ol. But if it is situated in CCC, here, the second carbon, it will not be called as 1, but it will become 2, propan-2-ol. So what I am trying to tell you here is, the naming of the alcohol, you have to look at the hydroxyl position. It depends on where the hydroxyl group is positioned in the long chain. In the long chain, you have to see where is it situated. So we are done with the naming. So let us go to Cikgu Azmi's book. This is the note that you have in your Cikgu Azmi's book in page 117. Let us look at the note. Okay, he simplified the note for you already. General formula CnH2n plus 1 OH, where N starts with 1, 2, 3. Functional group is hydroxyl group. And then, these are the physical properties of alcohol. Alcohol C1 until C11 are liquid at room temperature. Liquid, there is no solid alcohol. Solubility. Simple alcohol, methanol, ethanol, and propanol are very soluble in water. Simple means C1, C2, C3. Color, it's a colorless liquid, no color. Unless you add your own color inside, then it will become colorful. Odor, sharp smell and dissolve in water, very volatile, meruap. You put inside an evaporating dish for a while, it will evaporate, meruap ke udara. Next, boiling points. It has low boiling points, 78 only, compared to water, 100 degrees Celsius. The boiling point for alcohol is 78 degrees Celsius. Flame burnt with a blue flame. So those are the physical characteristics of alcohol. Now let us go back to your textbook and we look at the preparation of alcohol. How to prepare alcohol in the lab? Ethanol is the most important alcohol and has many uses. Most important alcohol. You have methanol, you have ethanol, you have propanol, and you have a lot of alcohol in homologous series until octanol. Okay, but the most important one and has many uses is ethanol. Two methods of ethanol preparation. In your syllabus, we are going to focus on ethanol only, ethanol. So two ways. A. Fermentation of glucose or starch. Starch kanji. Fermentation in bahasa Melayu is like membuat tapai. Okay? With the presence of yeast. Dengan kehadiran yeast. So I have attached one video, a YouTube video of a teacher conducting this experiment, fermentation of glucose in the lab. So you can watch it in the link that I will attach in your Google Classroom later. So that is A, fermentation. B is hydration. Hydration of ethene with the presence of a catalyst. We have learned this in the previous chapter about ethene. I hope you still remember that when we add water to ethene, I draw ethene for you first. C, double bond C. And then we have H. This is ethene, okay? When we add water in it, we actually will break the double bond. When we break the double bond, what you will have is C, you draw the atoms again, and you add this one, H, and also remember the bond is to the OH. So here we can get ethanol. If you still remember, we have enzyme, we have catalyst here, and with specific temperature that we have to use here. Okay, so that is the second way to prepare ethanol. 1, fermentation. 2 is hydration of ethene with the presence of catalyst. Okay, so let us discuss about fermentation of glucose first. Fermentation is the process, penapaian is the process in which yeast acts on carbohydrate, bertindak balas ke atas karbohidrat. Carbohydrate is sugar or starch. Why the yeast want to react on carbohydrate is to produce ethanol and carbon dioxide in the absence of oxygen. Tiada kehadiran oksigen. So, what is inside yeast? Yeast contain the enzyme zymase that acts as catalyst, which break down sugar or starch here into glucose. So, penampaian glukosa akan menghasilkan etanol dan karbon dioksida. For your information, those who know how to bake, you will understand why your bun is bigger at the end of the process of waiting. Because of the yeast. Yeast acts on the sugar inside the bun. So, it will produce carbon dioxide. That's why your bun jadi besar dan kembang. Sebab ada gas karbon dioksida. Chemical equation for fermentation. Glucose, C6H12O6. With the help of zymase enzyme in yeast, di dalam yeast, will produce ethanol and carbon dioxide. So let us look at the simple setup here. Setup apparatus of fermentation. This is the setup, a very simple one. You use a conical flask, okay, close it, and then you use delivery tube to deliver the gas from the glucose solution. As I have mentioned earlier, yeast will act on glucose to produce CO2. So carbon dioxide gas will be delivered here. Why is there lime water? If the lime water turns cloudy means the CO2 is present. Okay, so this is the setup of apparatus for fermentation, but do refer to the YouTube link that I attached for more information on how to set it up in the lab. So this is the first one. The second one, how to prepare ethene is hydration. Penambahan air ke atas ethena. Ethene reacts with steam H2O. Steam maksudnya this adalah dalam bentuk gas, okay, bukan liquid. At 300 degrees Celsius and pressure of 60 atmosphere with the presence of phosphoric acid H3PO4 as a catalyst. So this is this one is very important. The chemical equation, ethene plus H2O, which is steam in gas, okay, will produce ethanol. Both of these will produce ethanol. This is fermentation and this is hydration. Penapaian, penghidratan. Tambah yeast, tambah air. Okay. So this is the setup of apparatus for distillation, where you can see this condenser, Liebig condenser, where water in and water out here. What is water in? What is water out? Water in is the hose connected to the pipe in the lab. Water out is a small hose connected to the sink. Okay, ini air masuk dari pipe sinki. Ini air keluar dari air keluar ke dalam sinki. Remember, water in bawah, water out atas. Atas sebenarnya masuk dalam sinki. Kenapa begini? Because we want to have pure ethanol that will drip into the conical flask. I will attach a video on this one also, so please do watch the video. Now let us proceed to the chemical properties of alcohol. So, chemical properties of alcohol. All alcohols have the same chemical properties. All methanol, ethanol, propanol, butanol, pentanol. All have the same chemical properties. Why? It's due to the presence of hydroxyl group or H as functional group. The important chemical reaction involving alcohols are 1. Combustion, 2. Oxidation, and 3. Dehydration. Combustion first. Combustion means pembakaran. Alcohol burns in excess oxygen berlebihan, to produce carbon dioxide and water. Alcohol is flammable and burns with a blue flame without soot. Alkohol mudah terbakar. Okay, dan terbakar dengan nyalaan biru tanpa jelaga, no soot. So it's actually a clean fuel. So ethanol, oxygen, carbon dioxide, water. The combustion of ethanol releases large quantities of heat. So ethanol can be used as fuel for rockets. Not for cars, but for rockets. Alkanes, alkenes, and alcohols burn completely in oxygen, producing carbon dioxide gas and water. So let us perform the same step. You can perform the same steps as alkane and alkene to balance the equation. I hope you still remember, when you want to balance the chemical equation involving combustion yang melibatkan pembakaran, please start with the H first, C first, and then H, and then baru O. Remember, O can use pecahan. Okay, we can use fraction on oxygen. That is number 1. So after this, you go to Cikgu Azmi's book and please complete the exercises below. I will attach, but this is the first one. Okay, this is the exercise about combustion of butanol. Like I mentioned just now, all alcohol will have the same chemical properties. So butanol will undergo combustion with oxygen to produce carbon dioxide gas and water. Same goes to propanol, also will undergo combustion, and same goes to the pentanol. Please complete the exercise. Now I would like to proceed to the second chemical properties of alcohol, oxidation of alcohol, pengoksidaan alkohol. Alcohol can be oxidized to form carboxylic acid. So this is another homologous series, the fourth one that you are going to learn. So far you already learned about alkane and alkene, and now you are learning about alcohol, and next you will learn about this carboxylic acid. So when we oxidize alcohol, we will have carboxylic acid. When you use ethanol and you oxidize the ethanol, you can have ethanoic acid. Same goes to if you use butanol, you will have butanoic acid. And if you use methanol, you can get methanol is not involved. And if you use pentanol, you can have pentanoic acid. It's corresponding. Okay, so alcohol can be oxidized to form a carboxylic acid, a homologous series with the functional group COOH. This one is for carboxylic acid. We will learn in the next topic. Look at the general equation here. Alcohol, oxidation, reaction, suitable oxidizing agent. I hope you still remember. The oxidizing agent that you know so far are the common one that you know so far include acidified potassium manganate 7 KMnO4 solution and acidified potassium dichromate 6 K2Cr2O7 solution. These two are the common, yang lazim, yang biasa, agent pengoksidaan yang biasa. So let us look at the general formula again. Any alcohol oxidized by a suitable oxidizing agent will produce carboxylic acid. This is the general formula for carboxylic acid. CmH2m plus 1 COOH and a molecule of water. Example: oxidation of ethanol by acidified potassium manganate KMnO4 solution. This is ethanol. Okay, don't worry. Why is ethanol this and this different? This is what we call as condensed formula. Okay, why is it like this? Look at this structural formula. C is attached to H, H, H. That's why we write here CH3, because there are 3 H attached to it. Next, this C is attached to 1H and 2H. That is why we write CH2. And OH is the functional group, itu letak di belakang. This one we call condensed formula. So this is ethanol. Ethanol oxidized. We do not write the KMnO4 in the equation. No, because we only want to use the oxygen in the equation. So it will be 2O. 2 because we balance it. Okay, next. It will produce, since we use ethanol, so we will get ethanoic acid. This one, ethanoic acid. Let us see how to put the formula for the carboxylic acid for the first and second and third member. If the first member M is equal to 0, so we will have the formula for the first member will be C kosong H 2 times 0 is 0 plus 1 COOH. So actually this is the first formula, chemical formula for carboxylic acid, which is called methanoic acid. So the second one, we don't write this kosong, that's why I omit that. Okay, the second one is M equal to 1. So it will be C1H 3 COOH. This is the ethanoic acid. Remember, carboxylic acid is the only homologous series where the numbering carbon atom starts from 0, 1, 2, 3. The rest all start with 1, 2, 3. Okay, so what happened in the oxidation reaction? The purple color of acidified potassium manganate is decolorized in the reaction if you use KMnO4. But if you use K2Cr2O7 acidified potassium dichromate 6, you will see the color changes are from orange to green. Orange to green. In this reaction, ethanol is oxidized into ethanoic acid. Jadi pendek kata, untuk pengoksidaan alkohol, for oxidation of alcohol, we use two types of common oxidizing agent yang ada warna yang berbeza. Kalau kamu guna KMnO4, kamu punya warna solution akan bertukar dari ungu kepada tidak berwarna. Tapi kalau kamu guna potassium dichromate 6, acidified potassium dichromate 6, warna larutan kamu bertukar dari warna oranye ke warna hijau. Itu dua pemerhatian yang berbeza. Sekiranya guna KMnO4 lain, K2Cr2O7 lain. Okay, we done with this one. Next, we are going to learn about dehydration of alcohol. Remember, we are now learning about the chemical properties of alcohol. We have discussed combustion, we have discussed oxidation, and now we are discussing dehydration. Dehydration, maksudnya buang satu molekul air. Buang satu molekul air. Dehydration of alcohol involve the removal of water molecule from each alcohol molecule to produce a corresponding alkene. So if you have alcohol here, such as butanol, you will have butene. If you use ethanol, you can have ethene. If you use pentanol, you will have pentene. And you cannot use methanol because there is no methane. Tiada methane, tiada. Tidak wujud. Because methane tu kan satu, the carbon. Okay. So water removal, water molecules are removed, disingkirkan from the alcohol when alcohol vapor is flowed over a strongly heated catalyst such as porcelain chip, aluminum oxide, alumina, or concentrated sulfuric acid. I already explained this one just now. Methanol cannot undergo dehydration reaction. Why? Because there is no methane. Mana ada methane? Tiada. Because methane, the N is tiada wujud. Because no double bond. Okay. So example of dehydration of ethanol. This is ethanol. When you use porcelain chips as catalyst, you can have ethene. This is ethanol, this is ethene. Don't forget to remove one molecule of water here. Okay, so this is the chemical equation. Ethanol undergo strongly heated porcelain chips, flow through, dialirkan. I will show you the picture later. Will produce ethene and water. So this is the activity. This is the picture. And this was the question that came out in SPM 2020. So what happened here is, you will have a glass wool. Glass wool adalah kapas, wool kaca. It's a kapas that has glass in it. Soak in ethanol yang direndam, okay, dicelup ke dalam alkohol, and then you put inside. It must be horizontal, macam begini, mendatar, okay, and then you put some porcelain chip in it. You heat strongly strongly, and then you hit this one slowly. You will have, this one kan ada alkohol. So, apa yang akan mengalir di sini in the delivery tube is a gas. And that gas depends on what alcohol you use. If you use ethanol, you can get ethene. You use butanol, you can have butane gas. Okay, we must do this experiment. Don't worry. Okay, next. If we use propanol, we will have propene and water because we remove water. Okay, so alkene produced from the dehydration of alcohol has the following characteristic. Burns with yellow sooty flame. Decolorize the brown color of bromine water. Kan alkene. Alkene ada double bond. It is reactive, so it can decolorize the brown color of bromine. So alkene yang dihasilkan juga can decolorize the purple color of KMNO4 to colorless. This experiment you must do, and I will upload the instruction of the lab report. Okay? Walaupun belum lagi buat itu eksperimen, tapi tolong buat lab report sedia because this is very important, wajib. Okay, so let us go to the next one, the last part of chemical properties. Chemical properties of other members of the alcohol homologous series. All members of alcohol homologous series have the functional group OH. All members of alcohol have the functional group. Semua ada, which is similar to ethanol. Thus, other members of the homologous series also undergo combustion, oxidation, and dehydration. Okay, we are done with the alcohol so far. I will upload instruction about the homeworks that you need to do. All are in Cikgu Azmi's book and also in your textbook. That's all for today. I hope you can repeat the video, you pause, you do the work, and then you watch the video again, which part that you don't understand, to complete the works. And yes, you can text me if you do not understand. Thank you very much for your listening, attentive listening.